Hello everyone, I'm Dr. Godhan Raman. In this section, we are going to discuss with the problem of one-dimensional wave equation with zero initial velocity and non-zero initial displacement. See the problem? A tightly stitched string of length L has its end position at x0, xL. At t0, the string is in the form function of x equal to kx into L minus x and then released. Find the displacement at any point on the string at a distance x from one end and at any point any time t greater than 0. So first of all, look at the problem. When the problem is mentioned string, then it's one-dimensional wave equation because of the string only tightly stitched to one endpoint to another endpoint. When I'm giving the force, the wave is created. So therefore, now the problem I identified one-dimensional wave equation. Then next to check velocity, initial velocity 0 or non-zero. But in this problem, velocity is nothing to mention. So velocity value is not given. Therefore, when is velocity is not mentioned or velocity value is not given, then we consider with zero initial velocity. Now this problem, the function of x displacement value is only given. Based on that, first you write one-dimensional wave equation. So one-dimensional wave equation. So what is the equation of one-dimensional? Dou square y by dou t square equal to a square dou square y by dou x square. So this is our equation, one-dimensional equation. And then this equation to solve using method of separation of variable, we have some possible solution. So the previous video I have updated the definition, application, example, introduction, everything I have to upload in the previous video. Please go and refer. It will be helpful for the videos. So now the one-dimensional wave equation, this equation having some possible solution, but we are taking now only for the suitable solution. The suitable solution is nothing but, so the solution of this above equation, y of x comma t equal to a cos lambda x b sin lambda x into c cos lambda at d sin lambda at. Now we should consider this equation number 1. So this is our suitable solution. And then next, condition. What are the condition? Boundary condition, initial condition. So now see the problem. In this problem, x0 to L and then the time t0. Therefore, first condition, y of 0 comma t equal to 0, x 0, then the t is greater than or 0. Then the second one, y of L comma t equal to 0, then x is the length other end L. Then third condition, velocity when 0 we consider is the third condition. Now this problem, velocity with 0 initial velocity, therefore dou y of x comma 0 by dou t equal to 0. So for this condition is nothing but initial velocity, boundary condition, and initial velocity 0. So this is the t equal to 0 velocity 0. Then what's the next condition? So initial displacement value is non-zero, the given problem. So look at this problem, what is given? So y of x comma t equal to the function of x. So y of x comma 0 equal to k into x, then L minus x. L minus x. Now this is the t equal to 0. Now what we are going to find out, the constant, the 4 constant value we are going to calculate using this boundary condition and initial condition. So what is the first procedure? Because a, b, c, d value we are going to calculate. Now using condition 1. Using condition 1 in equation 1. So what is the condition 1? X is 0. So put x is 0 in equation 1. So what is the equation 1? Y of x comma t equal to a cos lambda x, b sin lambda x, c cos lambda at, d sin lambda at. So this is a solution, equation 1. In this equation, when I am substituting the value x is 0, y of 0 t, then a into cos 0, b into sin 0. Then the other term, no x value, therefore cos lambda at, then d sin lambda at. Now see the condition, boundary condition, the left hand side value 0. So therefore the condition, left hand side value y of 0 comma t 0. Therefore 0 equal to a into cos 0. Cos 0 value 1. Cos 0 1. Sin 0 0. Therefore this is a 1 plus b 0. C cos lambda at, d sin lambda at. For this equation, c cos lambda at, so 0 equal to a, c into cos lambda at, d into sin lambda at. Now you take this all the equation, because this is a non-zero, the whole equation to take it in the left hand side. The whole equation to take in the left hand side, because of these equations are non-zero. Now the term a 0. Now you consider this is the equation number 2. Now substitute equation 2 in the previous equation 1. So what is the previous equation? Y of x comma t equal to a term 0, therefore b sin lambda x, c cos lambda at, d sin lambda at. So this is the equation number 3. This is our equation number 3. Now consider, once you find the value of a, then you substitute in the suitable solution. Now I have, this is a new equation, new solution. Now using condition 2 in equation 3. So what is the condition? Put x equal to L. Put x equal to L. So when I am substituting x equal to L for the equation 3, y of L comma t, b into sin lambda L, c cos lambda at, d sin lambda at. Here left hand side, y of L comma t in the boundary condition. So look at the boundary condition, y of L comma t 0. So therefore the boundary condition y of L comma t 0, to substitute in the left hand side 0, b sin lambda L, c cos lambda at, d sin lambda at. For these values, now I'm just taking here the term, the whole term. When I'm consider this whole term is non-zero, so when I'm taking this left hand side, therefore 0 b sin lambda L. So generally what we are doing, this term to take it on the left hand side, so b equal to 0. Fine. If we consider b equal, in this situation, what is the possibility? b 0 or sin lambda L 0. These two possibilities. But the problem is, when we have b 0, you substitute the previous equation. This equation, when I am substituted whole term, because already a 0, when I substituted b 0, it's a trivial solution. Therefore, in this situation, B non-zero. B non-zero. Therefore, I'll take it B in left hand side, 0 sine lambda L. And then we know that sine n pi 0. Therefore, the 0 term I should take it sine n pi sine lambda L. Therefore, n pi equal to lambda L. To find the lambda value, n pi by L. This is our lambda. Now you consider this equation. So what is the equation? 3. Now we consider this equation 4. This fourth equation substitute in the previous equation 3. So substitute 4 in 3 equation. So what is the fourth? Lambda n pi by L. To substitute the previous equation y of x comma t equal to, then b sine lambda is n pi x by L. Then c cos lambda n pi at by L plus d sine n pi at by L. Now this is our equation number 5. Now what is the third equation? So using third condition in equation 5. Using third condition in equation 5. So what is the third condition? Differentiate partially with respect to t, then substitute t equal to 0. So what are the condition here? Now differentiate equation number 5 partially with respect to t. Therefore, though y of x comma t divided by though t equal to b sine n pi x by L constant we consider because no t variable. Then you are differentiating this term c cos function. When I am differentiating, it's minus sine n pi at by L by n pi by L. Then plus d into sine function. When differentiating, it's cos n pi at by L by n pi by L. Now this is a form. Now what is the next one? Once differentiated, third condition, when I differentiated, then put t equal to 0. Therefore, though y of x comma 0 by though t equal to b into sine n pi x by L. Then when I substituted this term c sine 0 by n pi by L, then plus d cos 0 n pi by L. I mentioned already sine 0 0 cos 0 0. Then the left hand side third condition, initial velocity 0. Therefore 0 equal to b sine n pi x by L, c term 0, d into 1 divided by n pi by L. From this, b non-zero, these are the non-zero, so I'll take this is the left hand side, d equal to 0. Now I consider this is the equation number 6. This 6 to substitute in the previous equation. So this equation to substitute. Therefore, y of x comma t equal to substitute sixth equation in the previous 5. Y of x comma t equal to b sine n pi x by L, then c cos n pi at by L, then plus d0. Therefore, in this condition, b and c sin n pi x by L, then cos n pi at by L. Now here this is a equation number 7. Here n is nothing but n is 1 to up to infinity. Now the most general solution is a linear combination of the solution. We should write the form of these two constants to consider the general constant. So y of x comma t equal to, this is a y of x comma t equal to summation of n from 1 to infinity bn. This bc constant to write in the generalized form. Therefore sin n pi x by L and cos n pi at by L. Now I consider this equation number 7. Therefore this is a 7th equation. Now what is the next one? Using fourth condition. Using fourth condition in the 7th equation. So fourth condition is nothing but t equal to 0. Therefore y of x comma 0 equal to n from 1 to infinity bn sin n pi x by L. When I substituted t0 cos 0. Therefore this y of x comma 0 for the fourth equation displacement is non-zero. The value is nothing but k into x L minus x equal to n from 1 to infinity bn sin n pi x by L. So when I am looking this form, k just multiply with x inside the bracket, k is nothing but Lx minus x square n from 1 to infinity bn sin n pi x by L. So whenever I am looking this, it's a similar way for the half range. So now use half range sine series. The length are given. Therefore when the function of x n from 1 to infinity bn sin n pi x by L, then to calculate bn equal to 2 by L 0 to L f of x sin n pi x by L into dx. So this is our half range sine series. This is the only we are going to apply with this problem to calculate the constant bn. Now this is a form. The left hand side, the form is nothing but f of x. Therefore now bn is nothing but bn equal to 2 by L 0 to L. What is the f of x? Left hand side value. So k Lx x square and then sin n pi x by L into dx. Now you just take constant to take it out. So 2k by L 0 to L Lx minus x square, then sin n pi x by L into dx. Now you just consider this term u, this term v. So integral uv dx. Generally we are familiar with the integrative formula. So someone is followed integral u dv equal to uv integral v du. The similar continuation only I am going to write this integral uv dx equal to uv1 u dash v2 u double dash v3 and so on. For this term u dash u double dash is our derivative, okay, is a differentiation. Then v1 v2 is integration. So therefore now I consider u term. So differentiation, then integration. So differentiation is nothing but Lx minus x square u. When I am differentiating this with respect to x, L x differentiation 1 x square 2x, then u double dash L constant, okay, because L1 in constant, therefore 0 minus 2. Then again to derivative of this 0, u4 0, it's going on. Now v is nothing but sin n pi x by L. So when I integrate this v1 minus cos n pi x by L by n pi by L. And then again to integrate this v2 equal to minus sin n pi x by L by n pi by L square. Then again integrate this cos, because minus of minus cos plus cos n pi x by L n pi by L cube. Now what is the formula? Formula is nothing but u v1. So u v1 minus u dash v2, then u double dash v3. So this only we are going to apply the formula. Now what is the formula? Now what is the bn? Bn equal to 2l. Bn equal to the previous form 2k by L. So 2k by L, 2k by L. Now u v1. So what is a u? Lx minus x square u. Then v1. So v1 is nothing but minus cos n pi x by L by n pi by L. U v1. So this is the formula u v1 minus u dash L minus 2x u dash into v2 minus sin n pi x by L by n pi by L square. U v1 u dash v2 plus u double dash v3. So minus 2 v double dash into v3. So cos n pi x by L by n pi by L whole cube. Now the limits is nothing but 0 to L. So when I am substituting 2k by L, substitute upper limit minus lower limit. My suggestion, so don't substitute the upper limit value in x, then only to find the value, right? But don't do that. If when I'm substituting the upper limit or lower limit value, the term 0, you just directly write 0. Otherwise, something happened, careless mistake possible. So when I substituted L, which place L I'm going to substitute? So this place is L, L, L. This is a L, this is a L, here I am substituting L. So in these places I am going to substitute L. So first term, when I am going to substitute L, and then this term are 0. So 0 into the whole term 0. Then minus, when I substituted for this term L, here minus L. But when I substitute L cancel, then we have the value cos 0 1, sin 0 0, sin n pi 0, cos n pi minus 1 power n. This is our values. Therefore upper limit first term 0, second term 0, then minus 2. When I substituted L, cos n pi by L cube. So this is the upper limit. Minus of lower limit, substitute 0. So 0 minus 0, 0, sin 0, 0, then minus 2 into cos 0 by n pi by L cube. Therefore, 2k by L minus 1 power n by n pi by L cube. Then minus into minus plus 2 by n pi by L cube. Now take any common term here. I'm going to take 2k by L into the denominator. To take it in the numerator, L cube by n cube pi cube, and then to take 2 common, therefore minus 1 power n plus 1. In this case, any cancellation possible, then you try to cancel. Now this L 2 times we have, then 2 into 2 4, so 4 k L square, and then pi cube 1 minus 1 power n by n cube. So this is our Bn value. This Bn to substitute in the previous equation. Now I consider the equation number. So previous, what is the equation I'm taking earlier? I think 7th equation. So the previous equation before to starting this. So 7th equation, this equation only I'm going to substitute Bn value. Now I consider the Bn equation is 8th equation. This is a 8th equation. So substitute 8th in equation number 7. Therefore, y of x comma t equal to n from 1 to infinity 4k L square by pi cube 1 minus 1 power n by n cube into sin n pi x by L. Then the 7th equation cos n pi at by L. So if you are stopped up to this, or to expand this term, to expand, otherwise, so you just stop it. This is our final solution. This is our final solution. If any prove that whatever they're asking the question, what is the possibility? Now substitute n equal to 1 for this cases. Any simplification possible, then you do it. Otherwise, this is our final solution. This type of problem is nothing but one-dimensional wave equation with zero initial velocity and non-zero initial displacement. Thank you.